Hi guys, so I'm going to be doing a little experiment here and feel free to do this at home. So you just want to get a tub and fill it a little more than halfway with water. Then collect some materials like a coin, a metal spoon, a plastic spoon, a pin, and a paper. Okay, so before we get started, let's make some predictions. What do you think will sink and what do you think will float? Let's start with the coin. So this coin is made out of metal. Do you think it'll sink or do you think it'll float? Next, let's take these two spoons. So one's plastic and one's metal. Which one do you think will sink and which one do you think will float? Let's see. Then we have the paper. So this paper is pretty light, as all paper is. So do you think it's gonna float or sink? And then we have the pin. On the front, the pin is plastic, and on the back, it's metal. So let's see what happens. We can start by dropping the coin in the water. It sank. Okay, next, let's put the spoons in. We'll put the metal one in first. Now let's put in the plastic one. Lastly, the paper and the pin. Let's see what the paper does. It floats. Let's do the pin now. It sinks. So why did the coin, metal spoon, and pin sink while the plastic spoon and paper floated? Density. Let's imagine you have a bunch of M&Ms. The closer together and more tightly packed the M&Ms are in the packet, the denser the packet is. But the more loosely and more spaced out the M&Ms are, the less dense the packet of M&Ms is. So basically, these M&Ms are called particles in real life, and particles make up everything, from a spoon to a coin to the water itself. So the same rules about density that apply to the M&Ms apply to particles. The more tightly packed particles are in an object, the more dense the object is. A less dense object will have more loosely packed particles. So remember when I said that water had density? Well, this is going to help us explain why some things float and why some things sink. When an object, like the coin or the metal spoon, has a density that is greater than the water's density, the object will sink. When some things like the plastic spoon or paper has a density that's less than the density of water, the object will float. And remember, density is how tightly packed our particles are in an object. And so now you understand why some things float and why some things sink. Why don't you go and try some of these things out on your own now? Try to guess if they will sink or float before you put them in the water. Thanks for watching. But wait, there's more. If you think you can understand a little bit more of a deeper explanation, you can keep listening. So a long time ago, there was this guy named Archimedes, and he did an experiment just like the one we did. After he did this experiment, he discovered something and called it Archimedes' principle. So, basically, what he discovered was that an object put into a liquid, like water, is acted upon by an upward force. This upward force is called buoyancy, and we'll get back to buoyancy in a second. So remember that object that was put into a liquid like water? Well, this object has to be equal to the weight of the liquid that was displaced by the object. So this liquid displaced or fluid displaced is basically a fancy term for how much water came out or how much the water rose when the object was put into it. So as water displaced increases, the buoyancy increases. Now, if the buoyant force is equal to the object's weight, then the object will float. But if this buoyant force is less than the object's weight, the object will sink. So now you know. Okay, so let's do a quick review. Density. That's how tightly packed all the particles are in an object. If an object has more density than water's density, it'll sink. If the object is less dense, it'll float. Archimedes' principle. This is the guy who said that buoyancy acts on any object put into a liquid. Which brings us to buoyancy. This is the upward force that determines whether an object sinks or floats based on their weight. Now I'm going to ask you to try out some more things on your own. Have fun, and I hope you learned something from this video.